All right, so welcome everybody. We're going to be talking about building and deploying applications to Apache Mesos. So before we get started, let me just kind of get a good feel of the room. How many people already are using Mesos in production? All right, we'll take that. How many people have no clue what Mesos is whatsoever? All right, that's good. How many people, I guess, are somewhere in between that, like maybe looking to use it, building applications? All right, fantastic. Cool. All right, so first, quick about myself. So my name's Joe Stein. Nice to meet all of you. I'm a developer and technologist by trade. About a year and a half ago, I started a professional service company focused on big data open source solutions, right? So we actually build out a lot of these type of solutions on Mesos and Kafka, Hadoop, Cassandra, really kind of fitting in between like vendors, right? The data stacks and Clouderas of the world, and working with organizations to train, develop, architect software solutions on open source technology. I'm an Apache Kafka committer and PMC member. Who here knows Kafka? Yeah, that's what I'm talking about. Awesome, great, cool. I also do some blogs and podcasts, so if anyone's interested in Hadoop stuff, I've had a blog and podcast for about 5 years talking about Hadoop. Some really great content in there. If you're interested in Hadoop, I'd say definitely check it out. And my slides I posted to my Twitter. So if you want to grab them now, you can. I'll post them to the meetup page, so you can grab them as well after. All right. All right, so for this talk, we're going to kind of just start with a quick intro to Mesos, assuming that most of you or all of you have no clue what Mesos is. We're going to talk just enough information so that the rest of the talk will be relevant, okay? Lots of good information online, so I may breeze through it, but if you have any questions, stop me, because I don't want to have the rest of the talk where you're kind of lost and not really understand where we are and what we're doing. Then I'm going to talk about Marathon. Marathon is one way that you can run your applications on Mesos. I'll talk about Aurora, which is another way you can run your applications on Mesos. And then I'll talk about custom frameworks. Custom frameworks allow you to basically natively run your applications on Mesos, right? So a lot of different ways that you can build and deploy applications to Mesos. And there's some rules around like when you want to do one versus the other. And at the end of the day, you may just end up doing them all. So we'll kind of talk about all of those. All right, so basically this is what the talk is about in a nutshell, right? It's like getting everything that you have running on Mesos, all right? So for the rest of the next 60, 90 minutes or whatever it is, like just kind of keep this in your mind, right? Like you should be thinking everything that you have should be running on Mesos. And if you have the idea of like, well, this, Redis shouldn't run on Mesos, yeah, it should, right? Everything should be running on Mesos. And we'll talk about how to do that, why to do it. If you have any questions, like, field them during the talk, after the talk, or whatever works best for you. Okay, so the origin, before we talk about even what Mesos is, right, I like to kind of talk about the origins of technology, right? So the origins of Mesos really comes from Google, all right? So fundamentally what we're going to talk about is like how Google runs their infrastructure, right? So the same way that Google put out like the MapReduce paper and this whole thing like Hadoop came, into fruition. It's a little different with Mesos, right? So with Mesos, no one really knew about Borg. Borg is the way, like the code name for how Google, like the code name of the data center operating system that Google has. They eventually changed it and called it Omega, and then wrote a paper about it. But Ben Hinman and a bunch of other folks from Berkeley, they had this idea, and they talked about it, and the Google people thought it was pretty cool, gave them funding at Berkeley, and we're here today talking about it. So some great papers, technical papers, some great videos to watch, really kind of understanding like, really where all this came from. It wasn't just some, hey, this is a good idea. Like it actually has very practical implications and real world scenarios behind it. All right, so let's talk about life without Mesos, because for me, the best way to understand what the benefits are about Mesos is talking about how you all are living today with your infrastructure. So this is what you do, right? You've got static partitioning, right? You've got DB1 and DB2. You got Web 1, Web 2, Web 3. Maybe you have 100 web servers, right? You're still calling them web servers, right? You may have some Hadoop servers, some database nodes. You've got all these different servers that you're basically saying, this machine is for this server, right? You may actually even go out of your way to go buy special hardware specifically for that server. And what you do is you say, like, let's say this is a naive rack, but let's say 2/3 of this rack you assign to the database, and the other 1/3 you assign to the web server. And that's all fine and well. The thing is that static partitioning is really bad, okay? With static partitioning, you're basically trying to deploy applications and hoping that the applications could utilize all the compute resources that are on those machines, right? So if you've got 10 machines, each with 8 core, right? You're hoping that your applications, each of them could use all 8 core. Some of them can't, right? Some of them single core machines, right? Some applications, they're very memory intensive, right? Caching servers. You need 96 gigs of RAM in those machines, and they have like one core use. So you're wasting 7, but you've used up all the RAM. And another part of your system, you've got lots of storage space, right? Because you've got a lot of data that you want to store. So there's a huge imbalance, not just across time, right? So things at 3 a.m. are different than 3 p.m., right? It's not just time, but even at any one point in time, your utilization curves and your applications, they look different, right? And that's what static partition is. This is what people live with today. It doesn't scale, right? Like if all of a sudden you need to now get more middle tier servers or database servers or Hadoop nodes, you're basically taking them away from the web applications. And you're doing that physically. You're actually consciously saying, I'm going to change up these servers and now run other processes on them. And anytime you have a failure, right, you're basically going to have downtime, right? You may be in a situation where you have Hadoop nodes, let's say, or even your web application where you can take down a rack and your application is still live and running, right? And that's great. But what you've done, whether you know it or not, is you've overutilized, right? You've over-provisioned your hardware resources. You've bought twice as much as you need just so that when the failure happens, you can still take in the load and everything's OK, right? And that's what static partitioning is. Is everyone kind of on the same page here as far as where we are today as a society and how we do compute and how we handle problems, right? This is what we do, right? OK, so this is a really naive example, right? This is a little bit more realistic, right? We don't have 10 servers, we have hundreds of servers, right? Some people have 10,000 servers, right? You've got all sorts of different servers. And when you're in the static partitioning world, you're actually going into, oh, rack 3, server 7 is a web server, right? You're actually having to go to specific machines and figure out what they are. And what we're talking about here is abstracting the hardware layer from the software layer at the computer, okay? So if you have 100 computers or 10,000 computers, it doesn't matter anymore, right? Start to think of those computers with a layer on top of it, which we're going to call an operating system, right? The same way you have an operating system on your PC or your Mac that abstracts the local hardware resources from the software application. That's what we're talking about here, right? We're talking about a layer of code that runs across all your servers that treats all the servers like one big computer, right? We're talking about an operating system, right? We're talking about a kernel for your data center, right? One operating system that allows you to deploy applications anywhere in your data center to any of your machines without really caring where they are, what configuration they have, and being able to consume the compute resources for where and how you want to deploy your applications, right? It's a really, really cool solution, and it works, right? So that's what Mesos is, right? Mesos is basically the kernel for your data center. It's an operating system. But as everyone knows, an operating system doesn't really do a lot for you, right? All it does is abstract the hardware from the software. So quick on Apache Mesos, right? It's scalable to 10,000 nodes, right? So it's been shown to, this is a really old slide. This is a year old. I think it's 4 or 5 times this, or for at least what people will speak to. It's fault tolerant, right? So slaves now can get restarted and upgrades and your tasks won't fail. As folks don't know, I don't know if anyone's used Twitter before, right? Remember back in the day, there used to be that whale that would come up on your page. Remember the whale, right? So Mesos is part of why Twitter fail whale doesn't happen anymore, right? Twitter runs their entire business on Mesos. So does OpenTable and a bunch of other organizations, right? It's become a much larger project over the years. It's got support for Docker containers. I'm sure everyone knows and loves Docker and all, right? And we could talk about Docker and why maybe when you run it in production, you want to think twice, or at least understand what you're getting into. It's OK to run Docker in production with Mesos. You just have to understand the trade-off. And we'll talk about that at some point. If I forget, someone remind me and I'll bring it up. But it can be done. You just got to understand the little dark alleyway that you shouldn't walk into. There's native isolation. So without Docker, you still get all the benefits with Mesos. So Mesos integrates with cgroups. Cgroups is originally contributed by Google to like the Linux kernel. And what cgroups does is basically isolate your CPU and your RAM and all these different resources and processes at the kernel level, right? So it's all that abstraction that you get from a hypervisor without all the software layers. Lots of different multi-resource scheduling that we'll talk about, right? So memory, CPU, disk, you can kind of put anything you want in there. It's kind of cool. It's very fine-grained resource allocation. So if anyone has a question about like, oh yeah, we use Yarn, how is this different than Yarn? It's really different than Yarn, right? It's like very fine-grained resources at the kernel level, right? It's not an application level system. It's a very low-level system to build other compute systems on top. Lots of different APIs, so Java, Python, C++ APIs for developing new applications on top of it, which is pretty much what we've been talking about. And then a web UI for viewing cluster state. Now, this might sound like, oh, there's a web UI, who cares? But when you've got thousands of machines and you've got 10,000 tasks running on 1,000 machines, it's really nice to be able to go to a web UI and click on a task and like go into the actual like drive where that's running and like look at the log files or whatever information is there. It's pretty helpful and very handy. Okay. All right, so this is kind of like the high-level architecture of Mesos. So Mesos uses Zookeeper, surprise, right? And it uses Zookeeper to basically handle state for the master failover. So the master failover is kind of the allocator and the controller part of the system that's figuring out where all the different resources are on the slave, and then with the frameworks where those resources should get scheduled. So if it fails, Zookeeper is just used for leader election so that a new master can come up and all the state is maintained and everything works and everyone's happy. And then there are slaves, okay? So masters and slaves is not like a failover relationship. Slaves is actually where all of your tasks run, okay? So if you have 10,000 computers, you probably have 5 that are masters and 9,995 that are slaves, that are actually giving all the compute resources to the one big computer. And this is kind of how it works, right? So in Mesos, you really can't do anything without a framework, right? It's not a tool for anything but like engineers, right? You can't give this to like your analyst, essentially, right? You can't give this to like, hey, I want to run a Spark job on it. Well, Spark has a framework that runs on Mesos. So you need to have these frameworks that basically run on Mesos. And what happens with the framework is basically you have a slave, right? So the slave has resources, right? CPU, RAM, disk, whatever resources it might have. And it says to the master, hey, master, I've got 4 CPU and 4 gigs of RAM. Master doesn't care, right? Master just gives it out to the frameworks and hands it out and says, hey, framework, here's 4 CPU, 4 gigs of RAM. Are you interested? And the framework can be like, nope, not interested. Or it could hold on to it and wait for other resources and then say, hey, yes, I want to take these resources that you've given me and I want to launch a task, right? So kind of flowing through here, right? Resources go to the master, framework sees the resources, framework decides that now you've got enough resources to launch the task. Because if you're launching, let's say, 3 Kafka brokers, and you want to launch 3 Kafka brokers, you need 3 different computers to give you, let's say, 8 core and 24 gigs of RAM. And unless you get all of those, you don't want to launch what you're trying to do, right? So it's not just one-to-one, it could be an aggregate. So the framework says, yes, master, please go ahead and schedule these resources. And the master says, no probs, I got it. And it will go and launch in what we call the executor, the resource processes. Okay, so you've got this you got Mesos at the core, right? And then you have this, it's really a paradigm more than anything else, this concept of framework, right? And a framework is really scheduler and executor. These are really important parts. So if anyone is confused or has any questions, this is definitely the time to ask because you won't understand anything else after this, right? The rest of the talk is about this. So you got this framework, right? And then you have on one side the scheduler. And the scheduler is deciding, based on the resources that are coming in, which tasks I should be launching, right? You're a Spark job, you're a Kafka broker, you're a Redis cluster, you're React or Cassandra, whatever it is, right? You're a scheduler looking at these resources and you're making the decision, yes, I now want to launch this. The executor is actually what does the launching, right? So the executor is code that's running on the slave that the Mesos slave is starting. The executor is a process that runs that's then launching all the other processes and tasks that is required by the scheduler. Really important concept here, right? Framework, right? Mesos core, framework, on one side the scheduler, figuring out what's going on, and then its buddy, the executor, who gets launched and then handles all of the execution of what has to happen based on the scheduler's decisions. Starting a Kafka broker, starting up React, starting up Redis, whatever you might be starting up. And when you start these things up, there's coordination involved, right? You can't just start a Redis server and it just runs, right? There's all sorts of different coordination that happens in a distributed system. And that's all what happens in the underlying protocol buffer transfers that exist in here, which we'll talk about and get to. So any questions about schedulers and executors or anything else? Yeah? In the back.
I wanted to ask, is there a notion of priorities, queuing, all those things that we have in classic schedulers like the grid engines?
Yeah, great question. So the question is,
because I see multiple schedulers there.
Yeah.
I mean, it's gonna get messy if you have multiple schedulers,
All right, so that's like
right?
3 questions, that's okay. All right, so the question is basically, do schedulers have any notion of priority, and how does that also work with other schedulers? I guess 2 questions, right? Okay, so we'll talk about one scheduler that has the notion of priority and preemption and how that works. So schedulers, they're native frameworks to schedulers, so you can build a scheduler to do whatever you want. But there are schedulers that do handle things like priority and preemption, and I'll talk about that as we go. So hold that thought. As far as multiple schedulers go, so there's some contention right now between the Omega paper that Google put out and scheduling, like doing true fair scheduling across multiple frameworks, right? Like if you have a scenario where you have a Spark scheduler and not a Spark scheduler, the Spark scheduler will most likely starve the other schedulers just in how this framework is written. And there's a lot of ways that you can control that. And I'm going to talk about some of those, right? So I'm going to talk about some of the ways that you can control starvation. But in I want to say it's this next version, 0.22 of Mesos. If it's not 0.22, it's 0.23. There's a new feature called modules that'll actually allow you to plug in a new allocator for the Mesos master. And the allocator is responsible for divvying out the offers to the schedulers and figuring out that fairness. So the answer to your question is, yes, it's a problem today if you don't understand the controls that you have to put in place to manage it. And moving forward, different organizations are building different allocators to handle better fair scheduling across the frameworks as well. So good story today for handling that, and there's a better one in the future. But it's doable, and we'll talk about roles and how all that works as we go. Any other questions? Where we are, schedulers, executors? Cool.
One question, actually. Is there any major advantage to having the schedulers be reactive in this sense rather than actively pulling for resources?
That's a good question. From a scale perspective, I think that the way that this was built is really to be able to handle tens of thousands of computers, right? It's really focused on making sure that this could scale at like a very large amount of machines. Knowing the people who write the software, like I'm sure that they thought about that. So yeah, I mean, if you think about it, like if you have 10 frameworks and they're all trying to pull and get resources versus like things like reservations, and we'll talk about attributes and resources and reservations, and especially now some of the new features, which are dynamic reservations, where you actually know that one framework had already asked for something, and you want to keep giving it back to that framework because they had already asked for it before. Right, all that intelligence, like it being in the master, scale aside, has a lot of benefit, right? Because you have that one controlling system, right? All right, so let's talk a little bit about some Mesos features, right? That's kind of the Mesos in a nutshell, but we're going to talk about some Mesos features which are important to understand, both from the rest of the talk perspective and just in general. So 2 of them are resources and attributes, okay? These are really 2 very critical parts of the Mesos software. Attributes are really nothing more than strings, okay? You basically can go and litter your slaves with attributes and set different information that might be appropriate to you, right? You might have some servers that are solid state drives, right? You might have some servers that are AS400s, I mean, whatever, right? It doesn't matter. The point is that you have different characteristics for things like hardware. Right? Maybe you have some machines that are for certain customers even, right, where you want to physically partition the data from one client to another. It doesn't matter. They're just strings. Okay? So what Mesos allows you to do is basically litter the cluster and the slaves with your strings as it's appropriate, right, and set these attributes on, and then do stuff with it. And we'll talk about the do stuff with it later in a little bit, right? But this is an important feature of Mesos, is that you've got these attributes, these strings out there, right? You know whether a server is in rack 1 or rack 2, right? Like the attributes can be whatever you want. And then you have resources, and resources is where it gets really exciting, right? So resources are basically scalars, and everything could be looked at as a scalar, right? You can do sets and some other variations, right? So you've got CPU, you've got RAM, maybe you've got some disk drives, maybe you have some other resource that you want Mesos to handle, right? So resources are something that the Mesos master is going to deduct from and control as people are asking for it, right? If there's 10 core and someone asks for 2, there's only 8 left, right? So Mesos is going to control that, right? The Mesos master is going to control the resources and actually making sure that the total sum of resources are managed by the Mesos master and divvied out appropriately, right? Attributes are just strings. They're just labels. But already talked about this, right? So out of the box, you get CPU, memory, ports just given to you. You can make anything a resource you want, right? So if you have 10 JBOD disks, each of them could be a resource, and when you deploy, each one of those disks can get owned by an application, and you don't have to worry about that. Here's some examples. So this is kind of where it gets a little nifty. So you have resources here up on the top. Right? You could actually specify how many resources this slave is going to manage. Maybe you have a machine that is running a couple hypervisors and it's only 50% utilized. Well, that's fine. You can give the Mesos slave the other 50% utilization. So it's a 24-core machine. You can start the Mesos slave up with 12 cores, right? And you can set the resources to be CPU 12. Or maybe you want to set attributes on it, right? Maybe you actually run in a data center, right? So you want to set the attributes being DC equals 1, floor equals 2, IL equals 6, rack is AA, server is 15, what have you. Or you run an AWS, right? So you want to set, US East 1 and your instance ID, right? You can really set your attributes as, whatever you want, right? Maybe your Docker version, because if you don't set your Docker version, then you don't know what version of Docker you're launching to. And when you upgrade Docker, everything on the machine dies because the Docker daemon dies. That was that point where he's paying attention. Sorry. Okay. Yeah. So that's definitely something to look out for. And that's it, right? So you've got resources and attributes, and that's what Mesos is basically controlling. And then you have these things called roles. So this gets to your question before about like how to segregate these pieces, is that Mesos will actually allow you to assign roles. You could say that these 8 core are going to go to production. 2 of these will go to staging, right? Or these 12 core go to Hadoop, and the other 24 core go to Kafka, right? So you have the ability to separate roles so that maybe you have different criteria of hard drives, and you want to have your Hadoop workloads on your JBOD drives, and you want to have your MySQL on your SD, your SSD drives, but you got all this overhead of CPU and RAM that's just not even being used, and you want to give that to Spark. Okay, so you create a role called analytics, and you give whatever available CPU exists to analytics, and Spark will just go and eat up every single available resource in that role for your cluster and do its computations on it, right? So roles are important because right now, as of today, you could have one scheduler starve your cluster. Right? One scheduler could sit there and be like, haha, I got all the resources. I'm not using them, but I don't care. I'm not giving them to anybody else. Right? It's totally possible, and it will happen. You gotta, right? Especially if you write it yourself, you gotta think about these things. So roles are a really good way today to help manage that. Moving forward, there's some new features in Mesos that are coming out that I'll talk about that kind of you don't have to do this moving forward, but still today, it's something that you have to think of and think about. Okay, so before we get to Marathon, any Mesos questions? Kind of going to start jumping into building stuff. Yep.
You mentioned integration with C groups. At what point does this happen? Is that the executor?
Yeah, so the question is, at what point does the integration with C groups happen? So it happens at the slave level when it launches a task. So when you configure a slave, when you install Mesos, C groups is not configured, okay? It's POSIX, so you don't get any isolation. You actually have to go and turn on C groups. Once you turn on C groups, then when a slave launches a task, that task is within a C group based on the CPU and RAM that was specified for that one task. Within that C group, every single other process, and we'll talk about this also, you can open up 75,000 processes if you want within that task. It will all be within that one C group, and it will all be governed that way, right? So things like CPU limits or soft limits, so you can go over, if you're given 2 CPU and you're the only one running on the machine and you use 4, it's okay. No one's gonna, it's fine. But if you're given 10 gigs of RAM and you use 11, you're just gonna get the carpet pulled right out underneath you, right? You're gonna get C group frozen, that's it, your task is dead, you're done, right? So for things like memory, like there's an upper bound, which is great. For things like CPU, it's all good, right? We're all just friends. Okay, all right, so let's talk about Marathon. All right, so Marathon is basically like the initd for the operating system, right? It's a way to basically start applications on this, operating system. The operating system just happens to be your data center, right? But it's still a way to start things, all right? It originally came out from Airbnb, so it's got lots of good production history, and it's one of the applications that Mesosphere is the company behind Mesos, right? Cloudera is to Hadoop as Mesosphere is to Mesos. I don't think they do that anymore in the SATs though, right? That whole section is gone maybe? That's all right. Show my age. But Marathon's cool, and we're gonna talk about Marathon in a little bit. Marathon is really great when you know you and your team are the ones who are touching your cluster, okay? So that's important, right? You know that like Marathon is a great tool, but it's like you have the keys to the kingdom, right? You can do anything. Good, bad, and indifferent. And you can do some amazing things with Marathon. And we'll talk about in a little bit what happens if you have users who you don't want to give the keys of the kingdom with, and we'll get into that. All right, so Marathon has some really cool features that we're going to talk about, and we're going to talk about how to deploy things to Marathon and how it works, and I really want to make sure that everyone leaves here with like I can go back and I can take my application and I can get it running on Mesos tonight, right? So Marathon has this feature called constraints, right? We talked about attributes and resources. Well, who cares about that unless you can do something with it, right? So Marathon has constraints. Basically, it takes the attribute field and allows you to put business logic around the attribute field. So one of those business logic are things like unique, right? You can say, deploy these 10 tasks, right? 10 Rails apps, let's say. And when you deploy all 10 Rails apps, you want to make sure that each of them are on a different host, because that's how you need to run your Rails app. I don't know, whatever, it doesn't matter, right? So you could say unique host name, right? And what will happen is that Mesos will not schedule any of those tasks on the same host. Or maybe you want to do like unique rack, right? You want to deploy 3 applications and you want to make sure they're all on different racks, right? You could do that. So there's the concept of unique, where you have an attribute, which is just a string, and then what you're doing with that string and creating uniqueness around it. There's also cluster. So clusters sometimes very useful, right? Let's say you have very low latency requirements where you need to have, like, let's say you're doing like RTB and ad bidding, and you need to have your bidder like right next to your ad server, always, right? On the same rack, right? You've got to have like the most fiber you can. So what you can do is you can cluster and say, okay, deploy this to the same rack, and it'll cluster all the applications into the same, whatever the attribute is, right? You could have the attribute be data center 1 and cluster DC1, and everything will just fall into DC1, or AZ, US East 1. Whatever the string is, it doesn't really matter, right? The important thing here is that we've got this cluster primitive that we can basically use inside of our application to make sure that our software is getting to the right point of the hardware. Because remember, We no longer know about slaves, right? The machines that are underneath, we don't know about them anymore, but they're still important to our application, right? Then you have group by. Group by is a really very useful one, right? Group by is basically going to say something like, go through all the possibilities continuously and make sure that I'm evenly distributed across them, right? So let's say you want to deploy something like HDFS to Mesos, right? You've got 3 racks. You want to have 10 data nodes deployed. Well, you don't want all 10 data nodes in one rack. That's silly, right? So you want to go 1, 2, 3, 4, 5, 6, right? You want to kind of group by, right? So group by allows you to evenly distribute the resources and the tasks based on whatever label you've set, essentially. Okay? And then there's like, I mean, pretty obvious, right? Where you can actually just say, you know, oh, hey, I've got SSD drives, right? And I need SSD drives for my application. So you want to make sure that when this application deploys, it will get to a label like SSD. Otherwise, don't run there. Because you need, if you don't have SSD drives, your application doesn't run. So you want to make sure that, you know, the SSD label is something that your application will, you know, match on. Or not. Maybe your application will die if there's SSDs underneath, right? Or maybe you need something that's not JBOD, and it doesn't matter what it is as long as it's not JBOD. So you also have the negative of that. So you can stop things from going to certain places if need be. OK, any questions on constraints or anything like that?
All right, cool. All right, yeah.
You had an example there where you specified a specific host.
Yep.
You define the host name
Yep.
specifically. Can you do a group by and just say, hey, just I want these 2 apps to be on the same physical host, but I don't care what the host name is?
So that would be more like cluster than it would be group by. So if you want to take 2 applications and force them on the same host name, then you would cluster by host name. And then you don't care. It would just happen under the hood magically. And yeah. Yep. OK, so running things in Marathon, I find, having talked to people about this, both on Teams on a daily basis and in events like this, it takes a little while for people to really like grok what you have to do to make things work. But it's really easy. Like it's really, it's like stupid simple, right? But you've got to kind of understand what you need to do to kind of make things work with Marathon, all right? So let's kind of walk through this. This is my pseudo bash script. So make believe this is bash, okay? It's bash-ish. And what we're going to do is we create a variable. We're just going to create a variable called tag. Don't worry about it, it's just some sample. It's not important right now. And then some app, we'll just call it XYZ. And then we're going to create an ID for this, which is just going to be tag-app, right? And then we're going to create a command. So command is basically going to be dash your script, host port 0, port 1, all right? And then what we're going to do is we're going to make a JSON, and we're going to post it to Marathon. And in that JSON, we're basically going to have the ID, right? So we've got the ID, right? We're going to set the command, which is a command, right? We're going to set the number of CPUs, right? And the number of CPUs is going to be 0.1. So the nice thing about Mesos is if you only need 0.1 like CPU, because that's all Nagios or whatever needs, then you can just give that app 0.1 CPU. You can set your memory, right? Because you need to set your memory. And then your number of instances. And then you're going to set some path for what's going to get downloaded, okay? And then you could set any environmental variable you want. So env here is basically going to do essentially an export of your, it's an environmental variable, right? So if you've got whatever environmental variables you need to set, you can actually pass them into here, and Marathon will set them for you. So if you ever have like an export some bash, whatever, this will do that for you, which is nice. OK, so let's kind of start to, and then you're going to post this to Marathon, right? So let's kind of hook this together. So this TGZ, right, so this tarball is basically going to hold your script, which you're going to execute. And what Mesos does for you is when it gets that tarball or zip or whatever it is, it's going to take it, download it to what it calls the sandbox. And the sandbox is just a directory and the slave. And it's going to unzip it for you, right? So think of it this way, right? Mesos will put your script in a place where it's unzipped your tarball and allow you to execute whatever you want. And we set ports here 0, 0, what this means is dynamically assign me 2 ports. So if your script here is like, let's say, a Play application or a Rails app or whatever it is, right? You just have to zip it up, give it to Marathon. Mesos will download it for you, and then you execute it as if you were executing it the command line manually. But instead of you doing it manually, Mesos is going to do it for you, right? And it's going to pass in host, because you don't know what slave it's on, right? You have no clue what slave it's on, but you may need to know this information. And then it's also going to pass in the ports. So here we need 2 ports. So you've dynamically asked for 2 ports, and it will pass in 2 ports, right? Once your script launches, you can do anything you want at that point, right? You can go and take a template file and change that template file as like Tomcat XML, the server conf, and have it be the ports that you were assigned and start listening on those ports and start accepting web requests, right? Anything that you could do with the command line by hand is basically what you're typing into here, and Mesos is automating that. And it's scheduling it, and it's making it fault tolerant, and if it fails, it'll make it run somewhere else. It's a really powerful, powerful system with a very simple, easy interface to run that.
Can you distribute those scripts with like BitTorrent and not be dependent on Mesos to download?
Not the best idea to do BitTorrent, but there are other ways to do it as well. So I'll talk about that in a sec. Okay. Yep. So the question was, I guess the question is,
I don't want it to be dependent on Mesos hitting my one repository. I want to distribute it myself.
Sure. So Mesos supports, I want to say, 3 different URIs. So it could be HTTP based, which means you could host it anywhere that you could host HTTP. It could be S3 based or HDFS. Okay. So as long as you can put some file on S3, HDFS, or HTTP, then wait. Then out of the box, Mesos will pull it down for you. If you want, let's say you want to integrate with BitTorrent, then you'd have to build your own custom framework, and we'll talk about that. Okay, so that would be cool, but that would have to be custom, and we could talk about how to do that. But out of the box, sure, yeah, whatever, sure, yeah, any URI, it doesn't matter. And same thing with like Docker containers. Like you can, when you deploy Docker containers, the URI is the image, and where that pulls from, it could be a private repo or what have you. So this is your script, and if you remember your script, right, you're basically launching your code. And when you launch your code, it's important to realize that like you're launching somewhere, you don't know where it is, but you've been told the host, which is great, and you know what ports you have to listen on, and most times that's enough. Right? If you're a web application, that's great. If you're a database server or a Kafka broker or React or Cassandra or some other system, you might need to do some other logic. Right? You may need to figure out who are the other tasks that are running in your cluster and get their information. Right? You might have to contact Zookeeper. You might have to call Marathon to get some other information. So as you start working with Mesos, you're going to be developing quote unquote your script more as your own layer within your infrastructure, right? Doing things like service discovery and really having a wrapper around your applications. But at the heart of it, like it's really just command line, right? Marathon doesn't actually have an executor, right? Remember how we talked about every framework, scheduler, executor? Yeah, Marathon's not like that, right? Marathon's just the scheduler. The executor is actually Mesos. So Mesos comes out of the box with what's called the command executor, which is like literally nothing more than like su-c, right? It just launches whatever you've given to it within a C group, and it'll just launch and pass you parameters. But that's okay because you're an application, and once you've got your parameters, it can be Python or Ruby or Go or Bash, whatever. You can do anything you want in here, right? Very, very, very powerful paradigm. All right. So let's talk a little bit about persisting data, because web applications are great, but at the end of the day, this becomes really awesome when you can put applications that, like Kafka as an example, where you actually want data to be stored there and you don't want it to disappear and you want to be able to get it to it later. So currently, to store data and persist data on Marathon, you have to write it outside the sandbox. Okay, that's just the reality, and it's okay to do. No one's going to yell at you. Maybe a couple people yell at you, but it's still okay. Everybody does it. And when you do that, since you got this tag and app right? Since you've already created this kind of structure of tag and app, then when you write your data to your local disk, var lib data, then you just need to organize it by tag and app. This way, if you launch a dev tag or a prod tag or a QA tag or an analytic tag, you can still have all these persistent stores all launched on the same slave, and none of them will bump into each other, right? I mean, these are really simple concepts once you start to understand them, but that's how you build systems on Mesos, right? Moving forward, this hack is not going to be required, so there's some really cool features coming in with like dynamic reservations where if you request a resource, you can say this is a static resource. The master will actually not give that resource to anybody else and will keep giving it back to you as a framework. So if you launch Kafka brokers there, right, and you said this is a static resource, then that will be your resource now, right? If you die and it crashes, no one else is going to get that offer. And when you start up again, you will get that offer and can start up your broker again. And when you do, it will be like local right there. There's also some cool stuff about mounting sandboxes and some other features that really make persistent data way better. But there's nothing stopping you from doing it today. People do this today, and it works great. And I continually recommend it. All right, any questions about Marathon? Marathon. Nope. All right, so let's talk about Aurora. Aurora is completely different than Marathon. And Aurora also goes to some of your questions that you had before about priority and preemption. Aurora really came out of, this is part my opinion and part what Bill Farner said, people who used to work at Google. Does anyone here work at Google or used to work at Google? Like I've asked every single person who's ever worked at Google that I've ever met, like what do you miss most from Google? Don't ruin it because everyone's always said Borg, so. Oh, right, there you go. That's the meetup answer, so that's okay. But most people I ask, like, what do you miss from Google? And people always say, oh, I miss Borg, right? And when Bill Farner started working for Twitter, he really missed Borg, right? And he missed Borg so much that he basically decided to write a scheduler on top of Mesos that fundamentally gave Twitter the ability to do what Google did in their data center with Mesos. So Aurora is, I guess, the closest thing that you can get to Google with Mesos. And it's an open source project, right? So it's an Apache project. It's written in Java. It's a really cool application. Aurora takes the concept of scheduler very differently, and basically Aurora kind of assumes that it's the only scheduler running, okay? So Aurora says, I'm going to own your whole cluster. It doesn't even care about all that role garbage that I talked about. It doesn't matter. Aurora is like, I will own your cluster, and I'm going to do that. And that's okay, because if you have an organization where you want to give compute resources out to analysts or marketing people or whoever, right? You don't want to give them keys to the kingdom, then something like Aurora might be better for you, because with Aurora, you have a very different architecture. And we're going to talk about that, and then we're going to talk about some of the benefits of when you want to use Aurora, because you have an organization that's not just your DevOps teams using Mesos, that you actually have like a team of analysts that want to run and use your compute resources, right? So we'll talk about a little bit of that. So Aurora is both scheduler and executor, but they call the executor Thermos, like thermosphere, mesosphere, thermosphere, whatever. I didn't name it. So Aurora is the scheduler. You got Mesos in the middle, starting tasks. And what Thermos does is it will actually open up processes inside of your task. And if anyone here has done marathon development, at least from my perspective, I've definitely got to the point many a times where it's like, I've just written Thermos, right? Like Thermos for marathon. So there's a lot that happens inside of this executor that gives you a lot of business logic and power that is great for your organization, right? So here's kind of the job object, and I decided to pull this out because it really highlights the features that Aurora gives you. So it separates things by environment and role, okay? So you don't have to willy-nilly hack this concept of segregation of tasks. It does this as part of the actual scheduler, right? So you can have an environment called dev, production, what have you, and you'd have different roles, and then you could have different quotas. Okay? So you could actually, as a user, be given a quota, right? Like an intern, you're an intern. All right, you get 10,000 CPUs. Cool, right? Fantastic. So I can go in as an intern and do whatever I want my 10,000 CPUs and whatever environment I'm allowed to do it, and I'm good to go, right? But what Aurora does is it has this concept called production. It's a really cool thing, production, right? Because sometimes things go wrong in production, and all of a sudden things that are not production just need to stop, right? And all of those resources of what was in production need to be shut down, and the production system that went down needs to automatically be started up, right? Aurora does that all for you automatically and calls it preemption, right? Very, very cool. So that intern who launched the 10,000 CPU Spark job, when a production issue happens, all that just is going to get killed. And the production resources will then get owned by the cluster and owned by Aurora. And then it has all the other cool stuff that you would expect with instances and constraints and CPU, health checks, all the other same stuff about Marathon, right? So let's talk about writing. Oh, yeah, we'll talk about this first, and then we'll talk about writing code in Aurora. Because I was like, oh, why wouldn't we just want to use Aurora all the time? Yeah, well, there's always a catch, right? So here's kind of the life cycle of Aurora. It's very much like Marathon, except it doesn't have this concept of like preempting, right? So it does a really very tight-knit job on not just starting and running tasks, but also killing, preempting, and restarting tasks. This is a very unique aspect of the Aurora scheduler. And this is how Twitter runs, Foursquare runs like this now, Moxie runs like this, Google, a lot of people use Aurora at this point. It's a nifty application. So this is Hello World in Aurora. So Aurora decided that for its DSL, how you write jobs, right? So in a Marathon, you write jobs by REST API posts, right? In Marathon, you're within the container always. But what they did is they decided instead of making a DSL, it's just Python. Okay, so if you've ever written Python before, then that's what this is. Okay, and all of these are pretty much custom with things like job, right? Because remember I showed you like the job object. There are some specific objects that you tie into when you're inside the container, and otherwise you can kind of write and do whatever you want. So this is a really naive hello world. You got your process. The command line is going to echo hello world. You set your resources. You say which process it is. You kind of link these together. You set your job. So you say what cluster you want, what role you want, your task name. You set what job it is, and then it's just going to run it and find a place in the cluster and run your little echo hello world. The reality of like building on Aurora is that you really have to build inside of the Aurora framework, right? Like to run on Aurora, you have to run on Aurora, right? You can't, if you're going to write some Go application or a Ruby application, like it's not going to work very well. So Aurora is a great application, especially if you have dozens or hundreds of people who actually need those compute resources for like the Mesos system, then Aurora is fantastic. If you're setting up a Mesos cluster and you're using it just for your operations and your team is the one who's managing it, then you should use Marathon. And in either case, you should think about writing your own custom framework, which we'll talk about in a minute, right? So this is what it looks like to get Kafka running on Aurora. I thought this was a good example, if for nothing else, just to understand like, both the power and trade-off of this type of system. So here you set up like a profile, right? With everything, you're setting locations of where to download stuff, right? Always. Mesos needs to download the executor from somewhere and run it, right? It's just not magically going to appear there. So you've always got some URI or something that you're download. You got a bunch of other like, important information like heap and version and some other fields here. We create a structure here called a process, right? This way you can, so this integration will actually pull the binaries from HDFS directly. That's what that process on the bottom is. And then this is just like makes your eye want to bleed, right? Just not. But it works though, right? I mean, and that's the cool thing is that like when you're building software in Aurora, it does work. There's a framework, and you have to work within the framework and within the container, right? It's very different than Marathon, where with Marathon, you can focus on your applications and build them, but it's you who controls the access to it. Here, anyone can go in and get compute resources and launch something. I'm not going to go through this. It's really not that, right? This is all online. If people are interested in running Kafka and Aurora, you can do it. So here's the process, right? This registry script is required to kind of match up and have like some service discovery. You kind of have to build and work on your own service discovery in that layer. And then all sorts of, like, these are all the Kafka settings, right, that you want to go and set when the Kafka broker starts. And then here you're going ahead and actually, getting to the point where you're running it, right? So here you're actually like running Kafka, right? So here this is the actual command line Kafka running starting class that you're going to start and execute. And then you've got your task, and it's got resources, but then you have different resources for staging, then you do production. And then you set up like different profiles for staging and production, and it's all within this one script, right? This one job is like handling everything within the one script. It's a lot. So that's it for Aurora. So just because we talked about Kafka on Mesos, if you want to run Kafka on Mesos, you should not use Marathon or Aurora. You should use the new framework that we've been building and working on. And we're going to actually talk about custom frameworks now. So it's a good leeway in to custom frameworks. So the reason to use custom frameworks is a fewfold. So Marathon is great if you have a team that is owning the production system, and they're the ones who are building, whether it's developer or admin, they're the ones who are building the software on the production system, right? Aurora is great where you've got people who, like maybe shouldn't like have access to production, who want compute resources and want to do things with these compute resources, right? Aurora is fantastic. But at the end of the day, these frameworks are abstracting a lot of features away from you that you're not accessing directly with Mesos, okay? One of the most important ones is, at least that I find, is that when these preemptions happen, or when your task gets killed for whatever reason, like in Marathon and Aurora, you just get shut down, right? You just get killed. You have no clue it's coming, and you just die, right? There's some applications that actually like to do things, before they get shut down and killed. So when you're building a custom framework, you actually have the ability to have like communication between the executor and the scheduler to do things like, hey man, I'm going to kill you. But wait, hold on, slow down, like come out. Then it could do its cleanup thing and like, all right, go ahead and shut me down, right? So there's a lot of different, flexibility that comes with frameworks. So we'll talk about those. And for real, if people want to try out the Kafka framework, it's alpha. Please try it out. It's kind of cool. So there's lots of sample frameworks out there, and I would definitely say like pick one of these languages that you like and go look at the sample framework. It's a really great way to understand both scheduler and executor and the protocol buffers that actually have to exist between the two and how they work together, which we'll talk about in a sec. Okay, so frameworks are made up of protocol buffers that are going back and forth between the scheduler and Mesos and the tasks and the executors, all right? And basically you getting called back within a container, right? So when you launch the scheduler, you're sitting on a callback, right? And you're getting called when things happen. When the executor starts, you're sitting, getting called when things happen. And then you're passing protocol buffers on those calls. It's that simple. So here's one of those protocol buffers, framework info. Framework info like kind of kicks off the whole shebang, right? So you've got, like the user you're going to run under, the framework name, framework ID, failover timeout, which is really important when you're like, if your framework fails, how long until Mesos kills all your tasks before your framework comes back online, right? You kind of want to set that to a high number because things fail and you don't want all your tasks to die. Checkpointing, same thing, right? So without checkpointing, when your framework fails, Mesos will just kill all your tasks. By setting checkpointing, if your framework fails, your task will keep running, even though there's no scheduler. And there's times to do this and times to not do it, right? For things like Spark, which is like a short-lived, quick scan, you don't need checkpointing. You don't want checkpointing, right? When the scheduler is done, your operation is over, the job is over. Role, so we talked about that before. So the default is star, but you could have the role be whatever you want, and it'll find a matching role within the cluster and consume those resources. Right now, you can only assign one role, and that's it. This is for Kerberos, and the rest is pretty obvious. And then you have task info. So task info, so framework info, right, is this information kind of being run by the scheduler going down through the executor, right? And then you've got this task info, which is all this other information related to the task. And it's actually getting to be pretty robust. This could actually probably take like 3 hours to go through in detail, so I'll make it quick, right? So you've got your task ID, your slave ID, you've got what resources are assigned, right? These are all other protocol buffers that exist in the mesos.proto structure, right? So resources are like the CPU, the RAM, what's associated to it, the executor that's associated to it, the command that's associated to it, whether it's Docker or eventually there'll be other things besides Docker like QEMU. And then some cool new fields here. So health check, not that new, but still pretty useful and cool. So Mesos will actually run for you based on the health check information that you set in here. So in Marathon, this exists. I'm not sure about Aurora, honestly. So in Marathon, you could set health check information, and it'll pass it down to Mesos. And what happens is Mesos will actually run whatever you want inside the task to check whether or not something's healthy, right? So it could be a bash script. It could run a URL ping. It could run whatever you want to determine this one task's health, right? So you have a very tight integration to basically, without Mesos having any clue what the software is, to basically give the rest of the infrastructure knowledge about whether this is alive or not, right? I don't know if folks have ever run name nodes before. Just because your name node is on does not mean it's working, right? Like, these are fundamental things, right? The app is up, but I hit it and it's blocking, right? Just because something is running doesn't mean it's working, right? So to be able to get into the is this really working or not is a very low level primitive that Mesos exposes. So when you're running your own framework, you can implement that, right? Labels are kind of cool. So labels are a new feature coming out that basically allow you to sprinkle extra information about the task once that task has been launched. So you know more information about it that you essentially need to know. So let's think of a good use case for that so people can understand this. Let's see. So let's say you launch 3 Kafka brokers, right? And you don't know, you have them as tasks, but you don't know which one is broker ID 1 and which one is broker ID 2 and which one is broker ID 3, right? Or you've got a Redis cluster and you've got one Redis server that's master, let's say. So the labels allow you to sprinkle this extra metadata about the task that can tell you information about it when you look it up, so you kind of know what that task is all about, right? Or like if you launch 2 name nodes, you can say, hey, this name node is the active one and this is the standby. So when you go to a name node and you look at it, you can just look at the labels and know what's going on about the information. This is just key value pairs. And then discovery info. This is also pretty cool. It's what allows the new Mesos DNS to run. It's just discovery information, right? So just finding more information. So Mesos doesn't even look at this. It's just more information that you're trying to tell people about your task that they might be interested in, essentially. And then there's task state, right? So when you looked at, and I kind of threw up and glazed over it quickly. When you look at like the Aurora structure of like how it handles tasks and killing and all that kind of stuff, right? At the end of the day, like this is really what's happening under the hood. And what I'd like to impart more than anything is that like we're at a really good time with this application where you've got systems like Marathon and Aurora that could allow you to be productive today on Mesos. But the future is really with things like this because the same way that we had mobile change computing back in 2009, right? Everyone's got a phone. Half of you are on it now because you don't want to listen. It's fine. It's cool. It's all good. Mobile changed in 2009, right? And it changed with apps, right? Everyone agrees? Yeah. So this is really what is now the feature with Mesos, is basically apps for your data center, right? Instead of having something run on Marathon, you can build a framework, right? You're a React person, or a Aerospike person, or a Rails person, or Nginx. It doesn't matter. Doesn't matter. Doesn't matter, right? Those are just frameworks, apps that run on the data center computer, right? And that's what frameworks really are, is basically these primitives that allow you to build and run on this kind of ecosystem and such. And it's really simple. It's like staging, starting, running, finish, failed, killed, lost, error. I mean, like, it's really straightforward. Now, the scheduler, this is kind of when we get into callbacks. So those are the protocol buffers. That's like 1/3, maybe, of the protocol buffers. So you can go to Apache.com. This is all open source, so you can go look at the code and look at the protocol buffers yourself. But when you're writing a scheduler, this is where the callbacks come in. So one function that you have to implement is registered, right? And you can see like scheduler, driver, framework, right? These are all parts of the protocol buffer that we looked at, right? The framework, right? Mesos will call you and will call this function, and you'll get instantiated, and you'll run, and you'll get this information, right? So when you're registered with Mesos, you'll get this call, and you can do whatever you want. Same thing with re-registered, right? If you fail and you come back online, Mesos will be like, oh, I know you were ready. So it'll re-register you, right? So you can know if you've been there before, and that state will be held for you. And then resource offers, right? So this is basically the function that you implement whenever a resource offer comes in. And this is, I mean, this is really simple stuff, right? Like, this is not like very difficult. Like, in terms of most computing problems, these are really simple things to build once you understand them, right? You just got to follow the API, essentially. You're going to get a resource offer. Every time the master has some offer for you or the slave, this function is going to get called. And you're going to do whatever you want with it, right? Hopefully, you'll decline the offer, because if you don't, you're going to starve your cluster. Please decline your offer if you're not going to use it. And then, sometimes offers are rescinded, right? Sometimes Mesos will just be like, yo, like, that's not yours anymore. I'm sorry, right? You get that information. You also get the information on status updates, right? So as things are changing within the system, you're getting called by Mesos, right? So if you think about the framework that you're building in the scheduler, you're really just like living in a container, and the container is calling some functions that it's specified for you, and you're just operating on those functions, right? It's a very simple, traditional paradigm. And then framework message, right? Because sometimes you get a framework message as well, right? So now you can parse that framework message and do something with it. Same thing when you've been disconnected or a slave lost, you're going to get these calls. Slave lost, executor lost, these are important because there's a difference between your task dying and your slave dying, right? Your slave dying means some admin maybe rebooted the computer, or the mouse chewed through the NIC card or whatever, right? The machine went away, which is different than your slave going away. And you want to do different things at those times, right? You want, like, if the slave is still there, maybe you just want to start a new task and make sure all the data is still available. But if the slave is gone, maybe it's time to go and start, an instance somewhere else and get replicating, because that slave is gone, right? So you don't have that ability with Marathon and Aurora to really see what's happening in the cluster and to make those like really intelligent decisions that your software needs to make. And when I say your software, like, I know everyone doesn't work for React here, or like Bash or whatever. Like, we're all engineers. We all work and have different business problems. Like, I'm talking about like internal R&D proprietary software, right? You should be thinking about like, oh, I build an ad server. How can I run my ad server as a custom framework, right? Or like, I build a compliance system. Like, whatever it is, like, all of these could and should be custom frameworks that essentially run on Mesos. Errors, they come in as well, blah, blah, blah. All right, so that's the scheduler, right? So you got your framework, your scheduler is sitting on one side, the Mesos master is telling you everything about it, figuring out all the resources, and then the scheduler is saying, I like that resource, go ahead and launch this, right? Now, when it launches that, what Mesos does is it downloads the executor, right? You give it a location of where to take your executable, and when that executable runs, right? Again, it's running in the Mesos container now on the slave and getting these callbacks, right? So now the executor starts. The first thing it's going to be is going to be registered. Same thing with re-registered if the executor restarts within a task, which is possible. Launch task is where the magic happens, right? So when you actually have like now for your task is launching, it's your responsibility to launch your task, right? Like, you could do whatever you want at this point. You could open up another process. You could just launch it in your same process. You could do whatever you want, but you've now been instructed that like now it's time to launch your task. Go ahead and launch your task. Do whatever you need to do. Kill task, right? This is where the I'm going to shut you down, do something about it comes in. More framework messages, right? So now framework messages are just going to go back and forth, right? There's no guarantee that framework messages will be delivered, but you can rely on them being there, right? So framework messages are a really nice way to like talk to yourself between executor and scheduler if you need. And then shutdown, right? Very simple, straight up concepts. This way you could have a clean shutdown. Errors coming in as well. And that's it. Yeah, does anyone have any questions?
Yeah.
I just wanted to see if I misheard, but do you recommend that people usually write their own framework per service?
So yeah, I mean, if you ask me that question in 3 months, it'll be different than I answer you now. So I would say if you've never used Mesos before, then you should probably get started using Marathon. And after a few days and you start to understand it, then look at your organization and decide whether or not you need to be using Aurora or Marathon. And then look at all your systems and try to pick out the ones that are going to make sense to build as frameworks, right? Like right now, there are a handful of frameworks, right? Like I think until there's like 100 frameworks, it doesn't make sense for you internally to go make everything a framework. It's way easier, and you don't get any deficiency from just running it on Marathon, right? Long term, right, a year from now or whatever, everything will look like frameworks, my opinion, right? You're just going to like, oh, I need an Nginx server. All right, just go download the Nginx framework, and then you launch within the Nginx framework. But until someone builds that, then what you do is you take an Nginx like install, you launch that on Marathon, and then launch your application inside of there.
You use Marathon to bootstrap, and then as
Yeah.
you work through your service, and you're like, right, this service is special, you need to do
Yeah.
things this way.
And some people actually run custom frameworks to do things like their own analytics, right, or their own stream processing. Like a lot of people, have done some really cool things in their own custom frameworks for their own businesses that are very specific. But that came out of the need of, oh, we can't do this on Marathon, right? And even though, like, I'm my little crystal ball, right, and that a year from now it'll all be custom frameworks and we'll have apps in the data center, which will be awesome. That's a year from now, right? Slow down, right? So, but today, Marathon's great, Aurora's great. Get started with those. Figure out how to get your systems running on there, and where you start to see those gaps and deficiencies, then custom frameworks start to make more sense. Or if you just want to be on the curve, depending on where you work, it depends, right? If you work for a product company, then custom framework might make more sense, right? It depends. Yeah.
Are there additional gotchas around using Docker with this beyond the versioning warning you gave?
Yeah, so it's not the versioning warning. I'll give it again because it's so important. So with Docker, Docker's great. I love Docker. Love Docker on Mesos. It's fantastic. The only gotcha really that I've seen so far is the upgrade path. So the Docker daemon, if the Docker daemon dies, all your tasks die. All your Docker containers die. So that's a single point of failure depending on how you look at it. So that's an issue. But you can't upgrade it without shutting it down. So if you have a slave that's running 1.4 and you want to upgrade it to 1.5, you have to shut down this is not a Mesos thing, right? You have to shut down every Docker container that's running on there, right? And then upgrade it. So in Mesos has a fully HA restart upgrade lifecycle. You could restart a slave and your tasks don't die. So you can upgrade a slave and all of your tasks stay there running and humming along, right? Like so for Twitter, they run like some stupid 20 terabyte Redis cluster. It just, right? Just crazy. You don't want to restart, a 6 terabyte Redis server. It's probably gonna take 30 minutes to start up, right? So it depends. If you have really quick systems that can just start up really quick and they can fail over, then maybe it's not an issue. If you have data that's residing there attached in volumes and you got to shut it all down just for an upgrade, that might be a problem, or at least you have to know about it before you get there. Besides that, go for it, right? Yeah, that's it. Yeah.
See, a very basic question. I didn't catch the part that the slave runs on a resident OS, or would it be straight up hardware, like.
No, resident OS.
Resident
Yeah, so CentOS, Linux.
So essentially, the resource strings and all could also capture the underlying OS, and you would have a distribution within your system or within your cluster about CentOS, Ubuntu, and based on the app you want to choose.
Yeah. So that is a fantastic example of where things like attributes make sense, right? Because if your application is going to install itself in Bash with CentOS Bash, right, with like yum, let's say, right, then you want to make sure that it only goes to a CentOS machine. So if you want to do that, sure, but that's where attributes come in. So then have operating system, CentOS, or like CentOS 5.7, right? CentOS 6.5, JDK 1.7, JDK 1.8, right? So you can use attributes for like where things are installed, and if no one's thinking this, like, you know, it's like, oh, where's Chef, where's Puppet? You don't need Chef and Puppet anymore. It's so cool. Right? It's great. No more Ansible, no more Salt, right? Like you may need them to bootstrap your machines, but once that's happened, like that problem doesn't exist anymore, right? The orchestration problem of having to manage and install and do all that stuff goes away, right? It happens within the container, right? Like when you deploy something, it will deploy everything that it needs to run right there locally, right? And if it doesn't, or it's conflicting, you can throw it in the container, and it'll run as well, right? So it's different, but it works. It's pretty cool, yeah.
You're saying like that you would actually you specify like the host OS, all the attributes that you would need in your application?
Sure.
Or like that's the typical approach, or could you install some of your dependencies as part, like that'd be a better approach to have them go to a machine that would have your dependencies?
Yeah, I mean, it all depends on your available hardware and how much of it you have, right? So I would say like for attributes, keep to things that are like not changing too much, like JDK, operating system, you know, maybe some other like Python version, you know, things like that. And then when you want to install, you know, jar files, all of that could sit in the sandbox, and you could just locally unzip them and run them locally within your class path. If you need to start changing up like Ruby versions and starting to do things that are going to conflict on the operating system, then maybe you should start thinking about something like Docker, because then at least you'll have an operating system within your operating system, right? To me, that's where the power of Docker comes in, is when, you know, hey, we run 1.7, but we have a new application that's using 1.8. Well, we don't run 1.8 anywhere. You know, we don't run JDK 8. Who cares? You know, install JDK 8 on a Docker container, install the app on a Docker container, and launch however many Docker containers you want on Mesos, and it just runs, right? And it doesn't conflict there either. So containerization with Docker is good for that type of packaging. Otherwise, I'd say use attributes or just install it locally. Like that's what we do for like when we use, one of my clients, we do HDFS and Kafka and a bunch of other stuff on Marathon, on Mesos. When we install HDFS, we just unzip it, change the configs, and start it. We don't install it locally on the machine. We actually have different Hadoop versions running on the same machine. They're all just corralled in different directories, right? You won't have that conflict of like, you know, static C libraries or anything like that. But if you get into that, then Docker becomes like more of a necessity.
I have one actually. I hope I don't get too much hate for this. Is there like a Windows builder? I ask only because it'd be cool to have a cluster of Linux and Windows, and you know, using tags and whatnot, we can schedule jobs and handle literally anything.
So you are not going. So Windows doesn't have a Linux kernel. So so you don't get C groups, okay? But there is new containerization coming out in Windows 10. So the new Windows 10 containerization, in theory, will allow Mesos to do proper isolation on a Windows machine. Now, the cool thing, besides running Mesos on Windows, is actually running Windows on Mesos, right? So what you could do is actually do things like, you know, like take a KVM image and actually launch dozens of KVM images on a Mesos cluster, and then give people like RDP access and have like desktops in the cloud, but they're just on your Mesos cluster. And all you're doing is starting up a KVM image. It's just a command, right? You just got to download the KVM image local to the machine, start the KVM image, and then boom, you've got like Windows with however many resources is needed, like running in your cluster, doing your compute, and you just RDP to it, and boom, you're in your machine. So that I think is like, yeah, it's like, yeah, that's great, right? Yeah, so that's good. The whole Mesos on Windows, with, like I said, with Windows Server 10, sure, because you get isolation then, right?
So that's Windows Server 10 with Docker functionality.
No, I think without Docker as well. I could be wrong, but I'm pretty sure without the Docker functionality, you would still get the same isolation. It uses the same underlying primitives, the same way that both Docker and Mesos use like the underlying like Linux containers, right? They just use a different, API there. Yeah, but KVM on Mesos is awesome. I'm hoping to see a QEMU framework sometime in the near future, just to make that stuff easier. But you don't need it to do it. You could do it. Just run it on Marathon. It works. It's cool. Yeah, everything can just run on Marathon. It's kind of cool. Any other questions? All right, cool. Well, thank you, everybody.